The morning of December 18th, 1942, a proving ground outside Nagoya, Japan. Imperial Japanese Army ordnance officer Captain Takeshi Nakamura stood behind a sandbagged position, watching his engineering team prepare for what should have been a routine firing test. Mounted on a sturdy test stand before him sat a machine gun that represented 18 months of desperate reverse engineering work. It looked nearly identical to the American M2 Browning .50 caliber machine gun that had been terrorizing Japanese forces across the Pacific since the war began. His team had captured several examples from defeated American positions in the Philippines. They had disassembled them completely, measured every component down to the thousandth of an inch, photographed every part, analyzed the metallurgy, studied the gas operating system, and painstakingly recreated the design using Japanese manufacturing methods and materials. The result sat before him now, ready for its first full operational test. Everything looked perfect. The dimensions matched, the weight was correct, the action cycled smoothly when operated manually. The lead engineer, a talented graduate of Tokyo Imperial University, gave a confident nod. The ammunition belt was loaded with 50 rounds of newly manufactured 13.2mm ammunition, the Japanese equivalent of the American .50 caliber cartridge. The test gunner, a veteran sergeant who had fired captured American Brownings in combat trials, settled into position behind the weapon. He pulled back the charging handle twice, chambering the first round. The mechanical sound was crisp and authoritative, exactly like the American original. Nakamura raised his hand, then dropped it sharply. The sergeant pressed the trigger. The gun roared to life with a satisfying thunder that echoed across the proving ground. Brass casings began ejecting in a glittering arc. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then silence. The gun had stopped firing. Not a stoppage that could be cleared with immediate action drills. Not a simple malfunction that could be fixed by adjusting the headspace. Complete mechanical seizure. The bolt was frozen halfway through its cycling action. The barrel was too hot to touch despite firing only 12 rounds. Smoke drifted from the receiver. Nakamura felt his stomach sink as he walked forward to inspect the weapon. His engineering team crowded around, their confident expressions evaporating like morning dew under a harsh sun. They had replicated the design perfectly. They had matched every dimension. They understood how it worked, but they couldn't make it survive even a single belt of ammunition. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This wasn't supposed to happen. Japan had entered World War II with machine gun technology they believed was adequate for the conflicts they intended to fight. Their Type 92 heavy machine gun, a 7.7mm weapon based on the French Hotchkiss design, had proven effective in China throughout the 1930s. It was reliable, accurate, and perfectly suited for infantry support against opponents who lacked armoured vehicles. Their Type 99 light machine gun provided excellent squad-level automatic fire. Their aircraft-mounted Type 1 and Type 97 machine guns had performed adequately in the early months of the Pacific War. But then they encountered the American M2 Browning .50 caliber machine gun, and everything changed. The Browning wasn't just incrementally better than Japanese weapons. It was categorically superior in ways that Japanese ordnance officers initially struggled to comprehend. The sheer destructive power was unlike anything in the Japanese arsenal. At the Battle of Midway in June 1942, just 6 months after Pearl Harbor, American naval anti-aircraft gunners, equipped with M2 Brownings, shot down, attacking Japanese aircraft with devastating effectiveness. The .50 caliber armor-piercing incendiary rounds punched straight through the thin aluminum skin of Japanese bombers and fighters, as if it were paper. In the Guadalcanal campaign beginning in August 1942, American Marines used M2 Brownings mounted on vehicles and in defensive positions to shred Japanese infantry attacks. The psychological impact was crushing. Japanese soldiers who had faced Chinese rifle fire with disciplined courage broke and scattered when 50-caliber rounds began impacting around them. Knowing that no cover short of substantial earth berms or concrete would protect them, the weapon's effective range exceeded 1 mile under optimal conditions. Japanese machine guns were effective to perhaps 800 yards at most. American gunners could engage Japanese positions from distances where return fire was impossible. The rate of fire, approximately 450 to 600 rounds per minute, depending on configuration, was sustainable for extended periods. Japanese machine guns had similar theoretical rates of fire, but their cooling systems and ammunition capacity limited practical sustained fire capabilities. Most significantly, the M2 Browning was genuinely universal in application. The same basic weapon served effectively in multiple roles with only minor modifications: infantry tripod mount for ground support, vehicle mount for mobile firepower, aircraft mount for aerial combat, anti-aircraft mount for air defense, naval mount for ship defense. This versatility meant American forces could produce one basic weapon in enormous quantities and deploy it everywhere, simplifying logistics, training, and maintenance. Japan had nothing comparable. Different roles required completely different weapons with separate ammunition types, spare parts inventories, and maintenance procedures. The logistical burden was enormous and growing worse as the war expanded. Japanese military leadership recognized immediately that they needed a weapon equivalent to the Browning. The problem was fundamental. Japan couldn't simply purchase Browning manufacturing licenses from Colt or other American manufacturers because they were at war with America. They couldn't import Brownings from neutral countries because American export controls prevented military technology from reaching Axis powers. They had to reverse engineer captured weapons and attempt domestic production using Japanese industrial capacity. The first intact M2 Browning 50-caliber machine guns fell into Japanese hands during the conquest of the Philippines in the first 5 months of 1942. American forces defending Bataan and Corregidor fought desperately with whatever weapons they possessed, including numerous M2 Brownings mounted on vehicles, in defensive positions, and on anti-aircraft mounts. When American 30 and Filipino forces finally surrendered in May 1942, after exhausting their ammunition and being cut off from resupply, the Japanese captured substantial quantities of American equipment. Among the prizes were at least 15 relatively intact M2 Browning machine guns. Japanese ordnance officers immediately recognized these weapons as critically important intelligence targets. They were carefully crated and shipped to Japan aboard fast transport vessels, prioritized above most other captured equipment. By July 1942, the first examples arrived at the Army Technical Bureau facilities outside Nagoya, where Japan's most experienced weapons designers worked. Senior engineer Colonel Jiro Ishikawa, a graduate of the Imperial Japanese Army Academy who had spent 3 years studying in Germany before the war, assembled a team of 12 engineers to examine the captured Brownings. They had specific orders from the highest levels of military command. Determine whether the M2 Browning could be replicated using Japanese manufacturing methods. If replication was possible, develop production specifications immediately. If replication was impossible, determine why and recommend alternatives. The team began with systematic disassembly. They removed every pin, spring, lever, and component, laying them out in precise order on numbered cloth mats. Each part was photographed from multiple angles using precision cameras. Every dimension was measured using micrometers and calipers, recording measurements to the nearest thousandth of an inch. The weight of each component was measured on precision scales. The metallurgical composition of each part was analyzed through spectroscopy and chemical testing. The team generated over 800 pages of detailed technical drawings and specifications. What they discovered was both enlightening and deeply troubling. The M2 Browning was mechanically ingenious. The basic operating principle used a short recoil system where the barrel and bolt remained locked together for a brief moment after firing, then separated as the barrel stopped and the bolt continued rearward. This system was conceptually simple, but required extraordinary manufacturing precision to function reliably. The barrel had to be precisely machined to exact tolerances. The locking lugs had to engage perfectly. The timing of the action had to be exact. Any variation in dimensions of more than a few thousandths of an inch would cause malfunctions. The American design philosophy emphasized interchangeable parts manufactured to tight tolerances. Any M2 Browning barrel could fit any M2 Browning receiver. Any bolt assembly could be installed in any weapon. This interchangeability required sophisticated manufacturing processes using precision machine tools, quality steel that could be machined accurately, and rigorous quality control that rejected parts outside acceptable tolerances. The Japanese engineers understood all of this. They could see the precision. They could measure the tolerances. They knew exactly what needed to be manufactured, and that's when they confronted the fundamental problem that would doom their efforts from the start. Japan's manufacturing infrastructure in 1942 was adequate for producing weapons using traditional methods that had worked for decades. Skilled craftsmen could hand-fit components to create functional weapons. Factories could produce acceptable quality when workers individually adjusted each part. But the mass production of precision, interchangeable parts to thousandths of an inch tolerances was beyond Japan's industrial capacity in most facilities. The machine tools needed for such precision manufacturing were largely imported before the war, primarily from the United States, Britain, and Germany. Domestic Japanese machine tool production existed, but couldn't match the quality and precision of Western equipment. Once war began, no more precision machine tools could be imported. Existing equipment had to serve indefinitely with no replacements available when it wore out. The steel quality was equally problematic. The M2 Browning used high-grade alloy steels carefully formulated for strength, hardness, heat resistance, and wear resistance. The barrel alone required steel that could withstand chamber pressures exceeding 18,000 pounds per square inch, barrel temperatures exceeding 500 degrees Fahrenheit during sustained firing, and hundreds of thousands of rounds of erosion from high-velocity projectiles and burning propellant gases. American metallurgists at companies like Carpenter Steel and Bethlehem Steel had spent decades developing these specialized alloys. They understood precisely how to mix iron with chromium, molybdenum, vanadium, and other elements to achieve desired properties. They knew the exact heat treatment procedures to harden the steel without making it brittle. Japan's steel industry couldn't consistently produce equivalent materials. The alloys weren't quite right. The heat treatment processes weren't as controlled. The resulting steel was adequate for many applications, but it lacked the durability needed for a weapon that would fire tens of thousands of rounds under extreme conditions. The engineers documented all these problems in their preliminary reports. They noted that exact replication would require manufacturing capabilities Japan simply didn't possess. But military leadership demanded results. The war was expanding rapidly. American Brownings were inflicting terrible casualties. Japan needed an equivalent weapon regardless of the difficulties. The decision was made to proceed with production despite known limitations. Engineers would modify the design where necessary to accommodate Japanese manufacturing capabilities. They would use available Japanese steels, even though they weren't quite equivalent to American materials. They would accept slightly looser tolerances where precision machine tools were unavailable. They would employ skilled workers to hand-fit components where necessary. Surely these compromises would produce an acceptable weapon, even if not perfectly equivalent to the American original. By September 1942, the first prototype Japanese copies of the M2 Browning were completed at the Kokura arsenal. The weapon was designated the Type II heavy machine gun. It looked virtually identical to the American M2. The dimensions were nearly exact. The weight was within 5% of the original. The operating principle was unchanged. Everything appeared correct on paper and during visual inspection. The first firing trials began in October 1942 at the Fuji Proving Ground. Engineers loaded belts of Japanese 13.2mm ammunition, essentially identical in dimensions to the American .50 caliber BMG cartridge. Test firers pulled the charging handles and pressed the triggers. The results? They were immediately disappointing and grew progressively worse with each attempt. The first prototype fired 47 rounds before the bolt jammed in the receiver, unable to complete its cycling motion. Engineers disassembled the weapon and found the bolt lugs had deformed slightly under the stress of firing, causing binding. The steel wasn't quite hard enough. The second prototype fired 33 rounds before the barrel warped from heat, throwing off accuracy and causing pressure fluctuations that eventually stopped the action. The barrel steel couldn't dissipate heat adequately and lacked the hardness to maintain dimensional stability at elevated temperatures. The third prototype fired 61 rounds, the best performance yet, before a firing pin broke. The pin was made from steel that was too brittle, fracturing under the repeated high-speed impacts. The fourth prototype fired only 19 rounds before the feed mechanism jammed. The dimensions of the feed components were slightly off due to imprecise machining, causing cartridges to bind rather than feeding smoothly. Engineers worked desperately to address each problem as it appeared. They tried different steel alloys for the bolt. They experimented with heat treatment procedures for the barrel. They adjusted dimensions on the feed mechanism. They strengthened the firing pin. Each modification improved one aspect, but often created new problems elsewhere. A harder bolt solved the deformation problem, but became too brittle and cracked. A different barrel steel resisted warping, but wore out faster from erosion. A modified feed mechanism worked better, but required hand-fitting, eliminating parts interchangeability. By December 1942, after 3 months of intensive development work, the best examples of the Type II heavy machine gun could reliably fire approximately 200 rounds before experiencing malfunctions requiring armourer-level maintenance. This was a genuine achievement compared to the initial prototypes that barely managed a few dozen rounds. But it was catastrophically inadequate compared to the American M2 Browning, which routinely fired tens of thousands of rounds between significant maintenance actions. The American weapon could sustain fire for extended periods limited only by ammunition supply and barrel heating. Gunners could fire 500 rounds, change a hot barrel in under 2 minutes using the quick-change barrel system, and continue firing with a fresh barrel. The process could repeat indefinitely, as long as spare barrels and ammunition were available. Combat reports from North Africa, where American forces were fighting German and Italian forces, documented M2, Brownings firing over 5,000 rounds in single engagements without mechanical failures. Pacific Theater reports showed similar reliability in harsh conditions of saltwater exposure, humidity, and sand. The Type II heavy machine gun couldn't approach this performance level. 200 rounds represented perhaps 3 to 4 minutes of sustained fire at normal combat rates. Then the weapon would need to be disassembled, inspected for worn or damaged parts, adjusted or repaired, and reassembled before it could fire again. In combat, this meant the weapon would be unavailable for extended periods precisely when firepower was most desperately needed. Japanese ordnance officers tested the Type II extensively, hoping to find acceptable employment methods despite its limitations. Perhaps it could serve as an anti-aircraft weapon where brief engagements were normal, but anti-aircraft use revealed new problems. The weapon was too unreliable for snapshots at fast-moving aircraft where you had only seconds to engage. Perhaps it could work as a defensive position weapon where sustained fire was less critical. But defensive positions required reliable weapons that wouldn't fail during desperate last stands. Perhaps it could be effective as a vehicle-mounted weapon. But vehicles encountered rough terrain and environmental conditions that stressed weapons, and the Type II's marginal reliability made it unsuitable. By early 1943, the hard truth was becoming impossible to ignore. The Type II heavy machine gun was fundamentally inadequate for any role where the M2 Browning excelled. Japanese industry simply couldn't replicate the American weapon using available manufacturing capabilities and materials. Captain Nakamura wrote this assessment in his official report dated March 15, 1943. The Type 2 heavy machine gun represents our engineers' best efforts to replicate American M2 Browning capabilities using domestic industrial capacity. Despite 18 months of intensive development, the weapon remains unreliable in all tested roles. The fundamental problem is not design knowledge. We understand completely how the American weapon functions. The problem is manufacturing precision and materials quality. We cannot produce components to required tolerances using available machine tools. We cannot produce steel alloys with sufficient strength and heat resistance using available metallurgy. We cannot achieve parts interchangeability necessary for field maintenance and logistics. Recommendation: abandon Type 2 production. Develop alternative weapons using design principles suited to Japanese industrial capabilities. Rather than attempting to copy American designs we cannot adequately manufacture. The recommendation was noted and filed. But abandoning the project meant admitting defeat, acknowledging that Japan couldn't match American industrial capabilities. Military leadership was unwilling to accept this conclusion publicly, even though the evidence was overwhelming. Production of the Type 2 heavy machine gun continued on a limited basis through 1943 and into 1944, primarily to avoid the embarrassment of complete cancellation. Approximately 300 examples were manufactured total over 2 years. Most were issued to training units where reliability wasn't critical. A few were sent to rear area defensive positions. Almost none saw frontline combat because field commanders who had access to captured American M2 Brownings flatly refused to accept Type 2 weapons, knowing they were inferior and unreliable. The contrast with American production was stark and humiliating. General Motors, Colt, and other American manufacturers produced over 3 million M2 Browning machine guns during World War II. 3 million weapons. The production rate at peak exceeded 10,000 guns per month from multiple factories running 24 hours per day. American production was so vast that M2 Brownings were issued lavishly throughout all service branches. Infantry battalions received them for heavy weapons companies. Armored units mounted them on every vehicle. Aircraft from fighters to bombers carried them. Ships bristled with them for anti-aircraft defense. The weapon was so abundant that it could be employed generously in roles where Japanese forces had to carefully husband their limited heavy machine guns. Japan produced 300 Type 2 copies over 2 years, and most didn't work reliably enough for combat use. The ratio was 10,000 to 1. One American factory produced more Brownings in a single month than Japan produced Type 2 copies during the entire war. This wasn't just a technological gap. It was an industrial chasm so vast that no amount of engineering, cleverness, or worker dedication could bridge it during wartime. The reasons for this massive disparity were rooted in fundamentally different industrial development paths. The United States had spent the 1920s and 1930s developing mass production techniques for consumer goods, particularly automobiles. Companies like Ford, General Motors, and Chrysler had perfected methods for producing millions of identical vehicles with interchangeable parts. This meant precision machining to tight tolerances, sophisticated quality control, standardized processes, and continuous improvement methods. When war came, these same companies converted their production lines to military equipment using identical methods. The mass production techniques that created millions of automobiles now created millions of weapons. The machine tools that machined engine blocks now machined machine gun receivers. The workers skilled in precision assembly now assembled weapons. The quality control systems that ensured cars worked reliably now ensured weapons functioned properly. Japan had not undergone equivalent industrial development. Japanese automobile production in the 1930s numbered in the thousands annually compared to millions in America. The automobile industry was small and largely hand-assembled vehicles rather than mass-produced ones. Precision mass production techniques existed in some advanced Japanese facilities, but they weren't widespread throughout industry. Most manufacturing still relied heavily on skilled craftsmen individually fitting components. This approach worked adequately for producing limited quantities of high-quality goods. Japanese swords, cameras, and silk were renowned for quality, but it couldn't scale to produce millions of identical items with interchangeable parts. The M2 Browning exemplified the difference. American workers, using precision machine tools, could manufacture receivers in minutes that took Japanese craftsmen hours to hand-fit. American quality control rejected parts outside tolerances, ensuring only good parts entered assembly. Japanese quality control often accepted marginal parts that skilled workers would adjust during assembly. American factories could produce thousands of identical weapons where every part was interchangeable. Japanese factories produced hundreds of weapons, where parts often required fitting by armorers. The ammunition situation revealed similar disparities. The M2 Browning fired the .50 caliber BMG cartridge developed by Winchester in the early 1920s. The cartridge was powerful, accurate, and manufactured to exacting specifications. American ammunition companies produced billions of rounds during the war using automated machinery. Quality control was rigorous. Defective ammunition was rare. Japanese 13.2mm ammunition was dimensionally similar to the American .50 caliber BMG, but the manufacturing quality was inconsistent. Primer sensitivity varied between production lots. Powder charges weren't as uniform. Case dimensions weren't as precise. This inconsistent ammunition contributed significantly to the Type II's reliability problems. Even if the weapon itself had been perfectly manufactured, inconsistent ammunition would have caused malfunctions. American Brownings experienced stoppages occasionally, usually traced to defective ammunition in specific lots that could be identified, withdrawn. But the ammunition quality was generally so high that weapon malfunctions were rare. Japanese Type II weapons experienced frequent malfunctions, partly because the ammunition itself was problematic. Powder that burned too fast caused excessive pressure spikes, damaging the action. Powder that burned too slow caused insufficient pressure to operate the action reliably. Primers that were too sensitive caused cartridges to discharge before fully chambered. Primers that were too hard failed to ignite consistently. The combination of marginal weapon manufacturing and inconsistent ammunition quality created a system prone to frequent failures. Even if one element worked properly, the other might cause problems. Meanwhile, American forces were discovering the full versatility of the M2 Browning through innovative adaptations. The basic weapon was designed for ground use, but American engineers rapidly developed specialized variants for specific roles. The AN-M2 aircraft variant reduced weight by using thinner receiver walls and lighter components, sacrificing durability for weight savings acceptable in aircraft where maintenance was performed after each flight. The M2 HB heavy barrel ground variant used a thicker, heavier barrel that could sustain fire longer without overheating, perfect for defensive positions and vehicle mounts where weight wasn't critical. The M2 water-cooled variant used a water jacket around the barrel for maximum sustained fire capability, used primarily on ships and fortified positions. Each variant shared common parts with the basic design, simplifying logistics. A bolt assembly from any variant would work in any other variant. Manufacturers could produce one basic design with minor variations rather than completely different weapons. Japan attempted nothing similar because they couldn't master even the basic design. Variants were impossible when the fundamental weapon didn't work reliably. The psychological impact on Japanese forces was devastating and cumulative. Soldiers who encountered American M2 Brownings in combat quickly learned to fear them with visceral dread. The sound alone was terrifying, a deep, thunderous roar, completely different from the lighter crack of Japanese 7.7mm machine guns. The visual impact of .50 caliber rounds striking near positions was shocking. Trees splintered, sandbags exploded, logs split. Anything less than substantial cover was effectively useless. The range was demoralizing. Japanese machine gunners could engage targets to perhaps 800 yards maximum. American Brownings could deliver effective fire beyond 1,200 yards, meaning Japanese positions could be systematically destroyed from ranges where return fire was impossible. The sustained firepower was crushing. American gunners could fire continuously for minutes, changing barrels when necessary, maintaining relentless fire that made movement impossible and demoralized defenders. Japanese defenders in fortified positions throughout the Pacific encountered this reality repeatedly. At Guadalcanal, American Marines used M2 Brownings mounted on vehicles and in defensive positions to devastate Japanese infantry attacks. Japanese soldiers advancing through jungle terrain would suddenly encounter sustained 50 caliber fire that shredded vegetation and men with equal ease. The thin jungle cover that provided concealment from rifles offered no protection whatsoever from 50 caliber armor-piercing rounds. At Tarawa in November 1943, American Marines assaulting heavily fortified Japanese positions used M2 Brownings to suppress enemy fire systematically. The weapons were mounted on LVT amphibious vehicles, on Sherman tanks, and in quickly established beach positions. Japanese defenders who exposed themselves to fire back were immediately engaged by multiple 50 caliber weapons firing from coordinated positions. At Saipan in June and July 1944, American forces used massive firepower advantages, including hundreds of M2 Brownings, to overcome determined Japanese resistance. The weapons were everywhere, providing both offensive firepower during advances and defensive firepower during Japanese counterattacks. If you find this story engaging, please take a moment to subscribe and enable notifications. Japanese forces attempted various countermeasures with limited success. Concrete fortifications with thick overhead cover could resist 50 caliber fire, but constructing such fortifications required concrete, steel reinforcement, and time, none of which were readily available on most Pacific islands. Natural rock caves provided excellent protection when available, but caves were fixed positions that could be bypassed, isolated, and reduced systematically using heavier weapons when necessary. Dispersed positions reduced the effectiveness of concentrated machine, the gunfire, but dispersion sacrificed coordination and mutual support. The defensive advantages of concentrated positions were often necessary despite increased vulnerability to American firepower. Part 2. The ammunition logistics told another story of industrial disparity that Japanese planners found increasingly desperate. Each M2 Browning in American service was supported by a supply chain that seemed limitless from the Japanese perspective. American ammunition ships carried hundreds of thousands of rounds to forward bases. Supply depots on secured islands maintained stocks measured in millions of rounds. Individual units received ammunition allocations that seemed wasteful by Japanese standards, where every cartridge was carefully rationed. American machine gunners could fire liberally at suspected enemy positions without worrying about ammunition conservation. If they saw movement in jungle vegetation, they could fire a 100-round burst to saturate the area. If they received incoming fire from an uncertain direction, they could spray the entire suspected area with sustained fire. This liberal ammunition expenditure was tactically sound because it suppressed enemy fire, destroyed concealed positions, and demoralized opponents, all while the supply system ensured more ammunition would arrive within days or even hours. Japanese machine gunners operated under completely opposite constraints. Ammunition was scarce and becoming scarcer as American submarines interdicted supply lines. Every round had to count. Firing at suspected positions without confirmed targets was wasteful. Sustained, suppressive fire was a luxury they couldn't afford. This forced Japanese gunners into reactive rather than proactive tactics. They had to wait for clear targets before engaging, allowing American forces to maneuver more freely. They couldn't sustain fire long enough to effectively suppress American positions, allowing American forces to return fire and call in supporting weapons. The industrial implications became even clearer when examining the production facilities themselves. The Detroit Arsenal, operated by Chrysler Corporation, produced M2 Brownings alongside tanks and other weapons using integrated assembly line methods. Workers specialized in specific operations performed repeatedly. One group machined receivers using precision equipment, another group assembled bolt components, another assembled barrels, another conducted quality testing. The assembly line moved continuously with each station performing its specialized task in sequence. Quality control inspectors stationed throughout the line rejected defective components immediately before they entered further assembly stages. The entire process was mechanized and standardized to an extraordinary degree. Blueprints specified exact dimensions and tolerances. Machine tools were set up to produce parts within those specifications automatically. Workers monitored the machinery but didn't individually craft each part. This meant production rates could be extremely high while maintaining consistent quality. A single American factory could produce more machine guns in a month than Japan's entire industrial base could manufacture in a year using traditional methods. Japanese factories attempting to produce the Type II heavy machine gun worked completely differently. Skilled machinists would receive drawings and create components using manually operated machine tools. Each part required individual attention and adjustment. The machinist would repeatedly measure, adjust, machine, and remeasure until the part met specifications. This process was time-consuming and required highly skilled workers who had undergone years of training. The assembled weapons would then go to master armorers who would test-fire them and hand-fit components that weren't working properly. Bolts would be individually adjusted to fit receivers. Feed mechanisms would be modified to ensure smooth cartridge feeding. Firing pins would be customized. This hand-fitting could create a functional weapon from marginal components, but it destroyed interchangeability and took enormous amounts of skilled labor time. The result was that a Japanese factory with 500 workers might produce 50 machine guns per month using these labor-intensive methods. An American factory with 500 workers using mass production techniques might produce 5,000 machine guns per month, a 100-fold difference in productivity. This wasn't because American workers were more skilled or worked harder. It was because the production methods and available machinery were fundamentally different. Japanese military leadership was acutely aware of these disparities but faced impossible choices. Resources allocated to machine gun production couldn't be used for aircraft production. Steel used for weapons couldn't be used for ships. Skilled workers building machine guns weren't available to build aircraft engines. Every decision involved painful trade-offs with no good options. The strategic bombing campaign against Japanese industry made the situation progressively worse throughout 1943 and 1944. American B-29 Superfortress bombers, operating from bases in China and later from the Marianas, systematically attacked Japanese industrial facilities. The Kokura arsenal, where Type II heavy machine guns were manufactured, was bombed repeatedly. The Nagoya industrial district, home to much of Japan's weapons production, was devastated by incendiary raids. The bombing didn't just destroy factories, it disrupted the entire supply chain. A machine tool factory destroyed in Osaka meant repair parts weren't available for machinery in Yokohama. A steel mill damaged in Yawata meant alloy steel wasn't available for weapons factories in Nagoya. A railway yard destroyed in Kobe meant raw materials couldn't reach factories in Tokyo. The cumulative effect was industrial paralysis spreading throughout the entire system. By 1944, many Japanese factories were operating at a fraction of their intended capacity, simply because raw materials, components, and transportation were unavailable. The Type II heavy machine gun program effectively ended in mid-1944, when the Kokura arsenal was heavily damaged in a B-29 raid. The damaged factory was eventually repaired, but it was converted to producing other weapons considered higher priority. Type II production ceased entirely. The 300 examples already produced were scattered across rear area positions in Japan, the Philippines, and other locations where their unreliability wouldn't be immediately catastrophic. Meanwhile, American M2 Browning production continued accelerating throughout 1944 and into 1945. The weapon was ubiquitous across every theater of operations. In Europe, American forces used M2 Brownings mounted on half-tracks, jeeps, tanks, and in fixed positions. The weapons proved equally effective against German forces, despite the Germans' reputation for superior engineering. At Normandy in June 1944, American forces brought thousands of M2 Brownings ashore. The weapons provided crucial firepower during the breakout from the beaches and subsequent advances through France. In the Pacific, the weapon became synonymous with American firepower superiority. By late 1944, American forces were conducting large-scale amphibious assaults on Japanese-held islands with overwhelming material advantages. The assault on Iwo Jima in February and March 1945 illustrated the disparity. American Marines landed with hundreds of M2 Brownings, providing suppressive fire. The weapons were mounted on LVTs, on Sherman tanks, on specially equipped landing craft, and in quickly established beach positions. Japanese defenders, heavily fortified in an elaborate system of bunkers and caves, fought with desperate courage, but were systematically destroyed by concentrated American firepower. The Japanese positions included a variety of machine guns, mostly 7.7mm Type 92 weapons, that had served adequately in China, but were completely outmatched in this environment. Some positions held captured American M2 Brownings taken during earlier battles. These captured weapons often worked better than Japanese equivalents because they had been manufactured to proper specifications originally, though ammunition shortages and lack of spare parts limited their effectiveness in Japanese hands. The battle for Okinawa from April through June 1945 showed the culmination of American firepower advantages. Japanese defenders fought with suicidal determination from fortified positions across the island. American forces responded with overwhelming firepower from every available source, including naval gunfire, artillery, airstrikes, tanks, and machine guns. M2 Brownings were everywhere, firing almost continuously during assaults. The ammunition expenditure was staggering by Japanese standards, but routine by American logistics capabilities. Individual weapons might fire thousands of rounds in a single day's combat, exhausting multiple barrels, consuming vast quantities of ammunition. Supply ships would arrive with replenishment within days. Japanese defenders, watching this display of industrial might, understood viscerally that they were fighting an enemy whose material resources were effectively unlimited. Every destroyed American weapon was replaced. Every expended ammunition belt was replenished. Every damaged vehicle was repaired or replaced. The American supply system functioned with machine-like efficiency that Japanese forces couldn't match or disrupt effectively. The development of specialized vehicles further demonstrated American industrial advantages. The M16 multiple-gun motor carriage mounted 4 M2 Browning machine guns on a half-track chassis. This mobile anti-aircraft weapon could deliver devastating firepower against both aerial targets and ground targets. The 4 guns could fire simultaneously, putting 2,400 rounds per minute into the air, creating a virtually impenetrable wall of steel. American forces produced nearly 3,000 M16 vehicles during the war. Each one represented 4 M2 Brownings, plus a mobile platform, fire control system, and ammunition storage. The entire system worked seamlessly. Japan produced nothing comparable because they couldn't even produce the basic machine gun reliably, let alone integrate it into a sophisticated mobile system. The PT boat program showed American versatility and abundance. PT boats, small, fast patrol torpedo boats, typically mounted 4 M2 Browning machine guns for surface combat and anti-aircraft defense. The PT boats themselves were mass-produced, with hundreds built during the war. Each one required 4 machine guns. The M2 Brownings were so abundant that equipping hundreds of small patrol boats with multiple weapons was routine rather than a logistics challenge. American aircraft increasingly relied on the M2 Browning as the standard armament. Fighters typically carried 6 or 8 M2 Brownings, providing devastating firepower. The P-47 Thunderbolt carried 8 50 caliber machine guns with over 3,000 total rounds of ammunition. The P-51 Mustang carried 6 guns. The F-6F Hellcat carried 6 guns. Bombers like the B-17 Flying Fortress carried 13 M2 Brownings for defensive armament. This meant every bomber required 13 machine guns, plus thousands of rounds of ammunition. American aircraft production exceeded 300,000 aircraft during World War II. Many of these aircraft carried multiple M2 Brownings. The total number of machine guns required for aircraft armament alone numbered in the hundreds of thousands. American industry produced them all without strain. Japanese. Aircraft armament followed a completely different philosophy born of necessity rather than choice. Japanese fighters typically carried 2 rifle-caliber machine guns and 2 20mm cannons. The mixed armament reflected ammunition shortages and industrial limitations rather than optimal design. The rifle-caliber guns used 7.7mm ammunition, available in larger quantities. The cannons used 20mm ammunition, which was much more scarce. Pilots had to carefully manage their limited cannon ammunition, using rifle-caliber guns for most targets and reserving cannon fire for critical moments. American pilots with abundant 50-caliber ammunition could fire liberally at any target. The psychological impact of this firepower disparity on Japanese pilots was crushing. American fighters could sustain fire for extended periods, walking their tracers onto targets. Japanese pilots had perhaps 5 seconds of cannon fire total before exhausting their 60 rounds per gun. They had to make every burst count because there wouldn't be many. The post-war analysis by American and Allied intelligence revealed the full extent of Japanese industrial struggles. Examination of captured Japanese weapons factories found facilities operating with worn-out machinery, inadequate tooling, and improvised methods that would have been rejected as unacceptable in American plants. Quality control was often visual inspection rather than systematic measurement. Workers were exhausted from excessive hours and inadequate nutrition. Materials were substandard substitutes for specified alloys. The Type II heavy machine gun represented the best efforts of talented Japanese engineers working with industrial capabilities that were simply inadequate for the task. The engineers understood the American design completely. They knew exactly what needed to be manufactured. But knowing what to build and having the industrial capacity to build it properly were entirely different challenges. A detailed technical report compiled by American investigators in 1946, after examining captured Japanese weapons facilities, concluded Japanese attempts to replicate the M2 Browning machine gun failed due to fundamental industrial capacity limitations rather than lack of engineering knowledge or worker skill. Japanese industry in 1942 lacked the precision machine tools, quality steel alloys, and mass production methods necessary to manufacture weapons of this complexity to adequate quality standards. No amount of effort could overcome these limitations during wartime. The report noted that Japan's industrial base was adequate for many purposes and had achieved remarkable results in certain areas like optical equipment and naval architecture. But the distributed mass production of complex mechanical systems requiring tight tolerances and interchangeable parts was beyond Japanese capabilities at the scale needed for modern warfare. The contrast with Germany is instructive and reveals that industrial capacity, not racial or cultural factors, determined success. Germany successfully manufactured the MG-42 machine gun, one of the finest weapons of World War II, using sophisticated mass production techniques. German industry possessed precision machine tools, quality steel, and production methods comparable to American capabilities in many respects. Germany's industrial base, though smaller than America's, was sophisticated enough to produce high-quality weapons in substantial quantities. Japan's industrial base was fundamentally different. Where Germany had decades of heavy industrial development, Japan's industrialization was more recent and less comprehensive. Where Germany had extensive automobile and machinery industries providing a foundation for weapons production, Japan had limited consumer manufacturing. Where Germany could produce precision components domestically, Japan often relied on imported machinery and tools. The human cost of these industrial disparities is difficult to quantify precisely, but impossible to ignore. Japanese soldiers throughout the Pacific faced American forces equipped with overwhelming firepower advantages. They fought with courage and determination that even their enemies acknowledged. But courage couldn't overcome industrial disparity measured in orders of magnitude. Japanese machine gunners firing 7.7mm Type 92 weapons were systematically destroyed by American gunners with M2 Brownings engaging from beyond effective return fire range. Japanese infantry advancing through jungle terrain were shredded by sustained .50 caliber fire that turned vegetation and concealment into kill zones. Japanese defenders in fortified positions were methodically reduced by concentrated firepower they couldn't match or suppress effectively. The Battle of the Philippine Sea in June 1944, sometimes called the Great Marianas Turkey Shoot, illustrated the cumulative advantages of American industrial might. American carrier aircraft, equipped with multiple M2 Brownings and supported by excellent pilot training and radar direction, destroyed approximately 400 Japanese aircraft while losing only 30 American planes. The Japanese pilots were brave, and many were experienced. But they flew aircraft with inferior armament, had inadequate training due to fuel shortages, and faced enemies with every material advantage. The result was slaughter. American fighters with 6 or 8 M2 Brownings could deliver crushing firepower in brief bursts. Japanese fighters, with their mixed armament of light machine guns and limited ammunition cannons, had to score precise hits with carefully aimed fire. In the chaotic three-dimensional combat at high speeds, American volume of fire overwhelmed Japanese precision requirements. The naval application of the M2 Browning revealed another dimension of American industrial advantage. American warships bristled with anti-aircraft machine guns. A typical destroyer might carry 8 to 12 M2 Brownings in various mounts. A cruiser might carry 20 or more. An aircraft carrier might carry 50 or more for close-range anti-aircraft defense. These weapons provided a crucial layer in the integrated air defense system that protected American naval forces with increasing effectiveness as the war progressed. Japanese kamikaze attacks in 1944 and 1945 faced this withering fire. Suicide aircraft approaching American ships would encounter coordinated fire from 5-inch guns at long range, 40mm Bofors at medium range, and 20mm Oerlikon, and 50 caliber M2 Brownings at close range. The M2 Brownings were the last line of defense, engaging kamikazes that penetrated the other defensive layers. The weapons proved effective in this desperate role. The 50 caliber armor-piercing incendiary ammunition could damage aircraft structures, ignite fuel, and wound or kill pilots. The rate of fire created a steel curtain that attacking aircraft had to penetrate. Many kamikazes were destroyed or damaged by M2 Browning fire in their final approach, causing them to miss their targets or crash without inflicting significant damage. Japanese planners developing kamikaze tactics understood they were sending men to their deaths against defenses that included dense concentrations of machine gun fire. The psychological burden of ordering these suicide missions was compounded by knowing that American firepower made even suicide attacks likely to fail. Young pilots would climb into obsolete aircraft loaded with explosives, fly toward American ships through increasingly sophisticated defenses, and most would be shot down before reaching their targets. Those who penetrated the defenses might strike a ship, but even successful hits often caused limited damage to large American vessels designed with battle damage, resistance. The industrial arithmetic was merciless. Japan expended trained pilots, irreplaceable aircraft, and scarce aviation fuel on kamikaze missions that achieved tactical results far infrequent to justify the losses. America expended M2 Browning ammunition, which was abundant and easily replaced, to defend ships that would be repaired even if damaged and returned to service. One side was trading human lives and capital assets for minimal gains. The other side was trading expendable ammunition for preservation of valuable ships and crews. The post-war rebuilding of Japan's industrial base reflected lessons learned during the war about modern manufacturing methods. Under American occupation, Japanese industry was rebuilt with emphasis on quality control, standardization, and mass production techniques. American advisors helped Japanese companies implement statistical process control, assembly line methods, and precision manufacturing. The results were transformative. Japanese industry that had struggled to produce 300 marginal copies of the M2 Browning during the war became, within 2 decades, one of the world's leading manufacturers of precision machinery, automobiles, and consumer electronics. Companies like Toyota, Honda, and Sony became synonymous with quality and reliability, demonstrating that the wartime struggles weren't due to inherent inability, but rather reflected the state of industrial development in the 1940s. Modern Japanese manufacturing, learning from both wartime failures and post-war American guidance, developed the Toyota production system that revolutionized global manufacturing. The emphasis on continuous improvement, waste elimination, and quality at every production stage represented evolution of the lessons learned when Japanese industry discovered it couldn't simply copy American designs without the supporting industrial infrastructure. The Type II heavy machine gun itself disappeared into history. The 300 examples produced were gradually withdrawn from service, scrapped, or lost during the war's final months. No examples are known to survive in museum collections today. The weapon was too unsuccessful and produced in too small numbers to warrant preservation. Meanwhile, M2 Browning machine guns from World War II remain in active military service worldwide, more than 80 years after the design was finalized. The weapon has served in every American conflict from World War II through Afghanistan. Millions of the original wartime production guns remain serviceable with basic maintenance. The design has been continuously refined but never fundamentally changed, testament to the excellence of John Browning's original engineering and the quality of American manufacturing that produced them. The story of Japan's attempt to copy the M2 Browning is ultimately a story about the limits of reverse engineering, without supporting industrial infrastructure. Japanese engineers understood the weapon completely. They measured every dimension, analyzed every material, and comprehended every aspect of the design. They knew how to build it. But knowing how to build something and having the industrial capacity to build it properly are fundamentally different challenges. The M2 Browning required precision machine tools Japan didn't have in sufficient quantities. It required quality steel alloys Japan couldn't produce consistently. It required manufacturing tolerances Japan's worn machinery couldn't maintain. It required quality control standards Japan's overworked factories couldn't sustain. It required an ammunition supply chain Japan's limited resources couldn't support. Most fundamentally, it required a mass production industrial base that took decades to develop and couldn't be conjured into existence during wartime. Japan had entered a war against an enemy whose industrial capacity exceeded their own by such margins that reverse engineering weapons was essentially futile. Even when Japanese engineers understood exactly what needed to be built, their nation's industrial infrastructure couldn't manufacture it in quality or quantity sufficient to matter strategically. Captain Nakamura's report from March 1943 had stated the truth plainly, abandoning attempts to copy American weapons and instead developing weapons suited to Japanese industrial capabilities. But by then, it was too late. Japan was already committed to a war where industrial capacity determined outcomes more than courage, skill, or tactical innovation. The Type II heavy machine gun that jammed after 12 rounds in that December 1942 test firing was a perfect metaphor for Japan's entire strategic situation. They understood what they faced. They attempted to match it through determination and effort, and they discovered that some gaps are too vast to bridge through willpower alone. The Americans had built their M2 Browning on a foundation of decades of industrial development, from Henry Ford's assembly lines to precision steel mills in Pennsylvania. That foundation couldn't be replicated quickly, and without it, even perfect knowledge of weapon design was insufficient. Japan tried to copy America's M2 Browning. They understood every detail of its construction, They knew exactly what they needed to build. But they couldn't survive trying to compete against an industrial system that was producing millions of weapons, while Japanese craftsmen struggled to hand-fit hundreds of marginal copies that jammed after brief use. The war was decided not just in battles, but in factories, not by soldiers alone, but by the industrial capacity that equipped them. And in that industrial competition, Japan was defeated before the first shot was fired. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.